Okay, so first of all, it's middle of the afternoon, everybody's falling asleep. How's everybody doing? Okay, all right. And my current day job for about the next 4 days is technically working in a school district, so I'm in the education sphere. This whole technical presentation is new to me. So I'm going to do a couple of raises of hands. How many people are here from Austin, Texas? Oh, there we go. Okay, so you'd recognize this picture. How about from outside the United States? Yeah, that's really amazing. This is a really great conference. Okay. Just a quick little bit about me. It was mentioned that I started programming in 1968, but it's been on and off ever since then. More recently, I've been working a little bit more on front end. So when Redux came out and I was given the task of doing an audio player, I got interested in these technologies like Active.js, and then this whole business of immutability and all the great stuff that Elm offers also got me interested in things like Scala and Cycle.js. Has anybody here used Cycle.js? Oh, cool. Because I've just put my toe in the water there. It seems like another system like Elm is very rigorous. But unfortunately, it doesn't have the happy compiler. It doesn't have no runtime errors guaranteed. So I think I'll stick with Elm. So this is the project I'm working on, a screenshot. It's a very small, privately funded startup in San Francisco, and the product has to do with optimizing scientific experiments. So another survey question. Does anybody know what FANG means? F-A-N-G? Okay, I just learned this. Oh, one person. I learned this from my financial advisor the other day. It's, of course, Facebook, Apple, Netflix, and Google, because that's what they care about. And those companies deal with massive big data. So now I understand there are 1,000 students enrolled at Stanford on machine learning, because that's what everybody's doing. But this company, Protolife, we specialize in small data. The reason being that these experiments the scientists are doing are typically pretty expensive, and they don't do a lot of them. So we've taken those machine learning algorithms and we've tailored them to deal with small data. So it's kind of interesting. I'm not the big or small or machine learning guy. I'm just a front-end guy, but that's what we're doing. But today, we're going to talk about animation. So when I started working on this project, we had a nice, really good JavaScript UI guy who introduced some of these animated widgets. And as we got through the development cycle a little bit more, I said, like, why can't I do this in Elm? So we're going to focus on this simple way to do animations, which is the CSS transition property. And I'll show you a couple, 3 little examples of this demo app that I just put up on GitHub to demonstrate some of the widgets that we're using. And then we're going to just dive into some Elm code and try to be exhaustive about like how you'd make this happen. Okay, so CSS transition. I don't know, maybe I'm preaching to the choir. You guys already know about this, guys and gals, but I'll go through it anyway. What it does is, given some initial state of your view and the target state that you want to get to, it handles all the math to interpolate from one state to the other. So all you need to do is in a style sheet, or you can do this in Elm in your view function, is to provide this transition property. And it takes, the word property is going to be heavily used here. It takes 4 subproperties. The first subproperty is the transition property. So in the example here, this is from Mozilla help page. You can see the transition width, transition height, transition background color. So those are the 3 properties that will be automatically animated once the transition kicks in. And we're also specifying here in the CSS those initial values, 100 pixels, and a background color. So the idea is you specify some initial value, either with your Elm view function or in CSS or some combination of it. Then you force an update, which changes the computed values of some of those properties, any of them. And immediately, if there's no delay specified, the transition will begin. And we can specify how long it goes, in this case, 2 seconds. In addition, it has a nifty function that the browser kicks off these DOM events that you can trap just like any other event in Elm. So transition run gets fired as soon as that computed change is picked up by the browser. Transition start usually is pretty much simultaneous unless you've had a delay specified. And then transition end gets fired, which is really helpful so you know when that transition has finished and you're now at the target state. And there's also a transition cancel message, but it's kind of hard to figure out when that fires. But I think some of the ways that might fire is if you remove the element that's got the animation happening from your DOM tree, you'll get that kind of message. Okay, so what kicks off this transition again? Well, it's some change from the initial state of the DOM to another state. And in the spec, they call this a style change event. And you can, because of the way Elm renders and things simultaneously, you can change many, many properties with one view function. So this one style change event could change the height and the width, et cetera. So this is an interesting quote, I thought, in a spec, which says that various things can cause computed values of properties on an element to change. Insertion and removal of elements, whether those elements have computed values and can change the styles of other elements through selector matching. So if you apply a style through a class or an ID, and then you change that in your view, that's a style change. Or changes to the document tree that cause changes to which selectors match elements. So there's a matching algorithm in CSS that can kick in these new values. Changes to a style sheet. So if you're using the Elm CSS library or something else, you could actually push a new style sheet out in the middle of your view function. That could cause the change. And other things. So you guys can, folks can worry about what the other things are. It's just to let you know that when you're doing these transitions, you've got to be a little careful and try and limit the changes specifically to those properties that you want to animate. Okay, besides the properties, we have these timing functions, and they give you basically anything you can write a cubic Bezier function for using these 4 variables will determine how the animation starts, transitions, and ends. And they have some built-in cases, linear, for instance, or ease in and out, which is the one I like to use, which is a nice, smooth, built-in transition. Also, in case you like to drive your users crazy, they have a stepping function transitions. So you can actually animate things to like jerk around on the screen using these stepping functions. So just maybe for those people who are going to be doing simulating old-style games, that might come in handy. Okay, and then what can you animate? Well, over 100 different properties here. Basically anything in the DOM that can be converted to a number or a Boolean or a string or a list of numbers. The system will have some rules to figure out how to interpolate those. And in addition to these 112 properties, anything in SVG can also be animated using this simple transition property. Okay, I think that's it for a quick description of what the capabilities are. Now let's look at 3 demos. These are little widgets that I've written. One is what I call an info box. The other is an alert, which I think everybody knows what that is. And then finally, a kind of carousel that lets you transition pages, translate them across the page. So that could be useful if you have a mobile app or a wizard where it takes you through several pages. Okay, let's try the demo. So let's see, I don't know if I can make this bigger, Control+. Yeah, okay. So I've got here is a simple app that has 2 pages on it, a home and an about page, and when you go between them, you get to see a new quotation. I just finished reading War and Peace on the plane to this conference, and thinking about artificial intelligence, this one kind of caught me. If we allow that human life can be governed by reason, if you place the word reason by, let's say, artificial intelligence, the possibility of life is annihilated. So I kind of like this quote because it's in keeping with some of the other humane topics that have been covered today. So anyway, hats off to Tolstoy. But let's look at these widgets. So the first one's the info box widget. That's where you have a bit of your customer base has experts as well as novices. So the experts don't need to see everything on the page, it just clutters it up. But the novices might want to learn about public domain law, like is this quotation public domain? Click the box, it animates open, and you provide more information. Click the icon again, and it closes. That's the info box. For the alert message, which actually is part of the DOM tree right now, you just can't see it, we don't have anything to click on. So we handle this by programmatically. So we hook up an event to, let's say, a button or something else that's happening. Some messages just came in from your web server. There's an error generated and cause it to open programmatically. So the alert system that we use for our application has another feature, which is, again, for novices and experts. We have a summary level, and then if the person's really interested in what's going on, they can click here and get more details. So you can see there's several visibility states going on here as the thing opens and closes, and then they can close this with either a program call or by clicking the dismiss icon. So that's one alert type. This one, say an info, has a slightly different dismissal value, so it self-dismisses after 5 seconds, or any time limit you want to specify. And then the final one here has a dismissal that it'll stay on the page just like the first alert did, but when you switch pages, it kind of goes away with the page. Oh, 2 animations at once. Okay. So those are the demos, really underwhelming, but I think useful to demonstrate it. So let's see how we put this together in Elm for the alert. So here's the structure of that alert, kind of shortened a little bit. What you see is there were, as you saw in the demo, there are 2 content areas, the summary and the details. Wrapping them are these 2 divs. So these are the actual elements that we put the transition property on. So what happens is, as you'll see, they start out with a height of 0, and then later on, when we want the animation to proceed, we give them a new non-zero height, and the transition takes over. And then here's that content area under the first wrapper, and then the detailed content area underneath. So obviously you need to figure that out ahead of time. And so then here's the setup. So you can set this up, as I said, in many different ways, but in our case, we actually have an associated CSS file that sets up these initial values. So you can see in this case, we have that transition on height for 1 second with an ease in-out function, and initial height is set to 0. That's for both wrapper, the wrapper on the summary and the wrapper on the details. And since the overflow is set to hidden, the user doesn't see it. Then later, when we're ready to make when we've calculated the height that needs to be set and we can begin our animation, we can use the view function in Elm to paint this with a style attribute. So you can see there, we've calculated the height in a variable called ht, and we pass it htpix to this style function. As soon as that gets rendered into the virtual DOM, that's your style change event, and the transition will start to happen. So let's look at the code for maintaining the state of the alert, because we have to keep track of the various visibility states. As you saw, it can be hidden, it can be showing the summary, it can be showing the details, or it can be transitioning from one place to another. And we're going to be changing that height value and creating that, those animations to kick off based on that visibility state. And then, as Jonas was talking about this morning with the map business, we try to keep as little state information as possible in this module. So what we need to keep track of basically is that visibility and the height values that we're going to use for the transition. Everything else, like the text or the HTML content that can be displayed, we can use, put in our config for the alert. It doesn't have to be stored in this changing property set. Okay, so we saw in the info box how you could just click on an icon and it would cause the animation to begin once we know what the height is. We're going to see in a few slides how we get that height. But for the alert, there's no event that we can pick up. There's no event that we can handle in our view function. So this is the first of a couple of sticky points that are probably the big takeaway from this, if you already know about CSS transitions. So how do we get information about the DOM tree, the element's height, etc., from the DOM into Elm if there's no click? So my answer is to use a custom DOM event. And we have to go to JavaScript because I don't believe there's any way to do this from Elm itself. And create a new type of event. In my case, I'm calling it alert sizes, and dispatch it so that it can be handled by that wrapper element in our view function. There is another way to do this, and that would be using subs in a port, as Murphy described, where you could actually have the JavaScript get the height right there and just push it to your app. In a subscription, you get a message that would contain the height. But I like this approach. You'll see when we get the view function that we handle all the events, and this is just one event. And it turns out we can actually get the height of that element in Elm. So this picture, I think, has been seen by a lot of people and probably should be part of the Elm tutorial and documentation. This is courtesy of Ossi Hanhinen, who's here today. So it's a picture of the typical cycle of Elm model that gets displayed in a view. The view, as we saw, could receive an action like that alert sizes event, update the model, update those properties, get the heights, change the model, and again, we cycle around. So everything is wonderful if you're in a pure Elm world. However, if we're coming from JavaScript, we're firing that event off, we've got to make sure that the element actually exists in the real DOM tree. So what this picture is glossing over is this animation frame idea. So in the Elm runtime, when you call your view function, it's actually queuing up a whole bunch of functions that are going to compare what you want to have in the document versus what's already there. And all of these comparing and changing happen in synchronicity with the browser's animation frame. So there's actually a little time delay there that you need to be aware of if you're working in JavaScript and you expect all those elements to already be part of the DOM. So this is how I handled it in this case. Since we already were in JavaScript, on the JavaScript side, you can call this function called request animation frame, and we'll wrap that code that sends off the alert sizes event in this request animation frame. So it won't be called until all that stuff is ready. So by the time dispatch alert sizes gets called, those wrapper elements and everything are actually part of the document. So there are two other methods at least for handling this animation frame synchronization. The other two you can do on the Elm side. One has to do with getting a subscription to a to a function in a module called animation frame, funnily enough, and waiting for that subscription to arrive. At that point, you know that an animation frame has cycled through and you can proceed. And the other way is to just purely delay whatever you're doing for a fixed amount of time. That's a little bit of a hack, but that also works. Okay, so we can assume that somebody told us to fire off that custom event. So here's the code that actually does it. So what we're going to do is change our state to say we're opening, but we're starting out with initial heights of 0, and then we're calling that port open alert next frame, and that's what's going to fire off the event. So let's assume we can catch that event, like a click event. How do we find the height of the elements? Because they're dynamic. Depends on what content you put in there. On JavaScript side, you could just write code that gets the element, goes through, and finds the offset height. Turns out you can do the same thing in Elm. This was something I learned from a blog post by a guy named Søren Dubois, I think it's pronounced. He's from Denmark. And he goes into the fact that if you have an Elm event handler, you get passed as the argument to that the decoder for that event, the event itself. And one of the main things in an event is it always has a target. So it turns out you can use JSON decode at and just walk through from the target to a child and then get the offset height, just as you would if you were writing it in dot notation in JavaScript. Very powerful. Plus, you're assured that if this works, you're getting a float value back, not just some random undefined value. Similarly, for our details element, which is a little bit farther nested, the event starts at that same target element, but we're going to go down a little bit deeper. So we go to the first child, the last child of that one's first child, and then we get the offset height. So it's just like writing JavaScript, but we're in Elm. It's type safe. Much better idea. Then we can take these two values that are being decoded for the height and map them together, pass them to a function or a Lambda function here, and create a resized message that we can send to our application. So this is the complete cycle from firing off this DOM event to decoding it, to putting it in a handler, and then creating a message. So the ultimate result of this resize handler is a message called resized is passed to our update function next cycle, and it's got not only those two heights, but also the DOM ID in case we're interested in that. So what I was talking about, why I like this approach, is that the alert sizes event comes in just as the transition end event would, or a click or anything else. It makes it very clear which messages are coming in. You don't need subscriptions, although you probably end up using them for something else. So, but I really like the simplicity of this one. So here we're catching that alert sizes, passing it off to that handler you just saw, and the result is there's going to be a message coming in to our update function. And when the message comes in, what do we do with it? Well, we can take the DOM ID, those two heights, and of course change the state of our model. That's the whole point. So at this point we can update our model. We can say, okay, we got the height. Now our visibility is going to be the summary level, and we will cache away those two heights into the properties for that alert. And then finally, when we're ready to display the alert again, we've been displaying it the whole time, but it's been invisible. Now that we have a visibility of summary, we spit out, okay, we're going to take that summary height, add 10 for padding, and change the height, and put that on our style. So you can see there are a couple of other cases here. When you get to the details level, that would even be larger. We have the summary height and the details height and some padding. Or when we're closing the alert, we'll change it back to 0. So each time you make one of these changes to the height and the style for that element, those transitions are going to start. So that's it. I don't know if that was too fast, but I think I made it. I'd like to thank Daniel Packard, who was on our team, who wrote these initial animations using JavaScript and Bootstrap. And Brian and Luke for doing this conference, which I've already learned a lot. I hope you guys have too. And as been said before, this community, which I think is the key thing. I felt the same way when I was starting in the Ruby on Rails thing back in the early days, this incredible sense of positivity and support for each other. So terrific Slack channel, and these people who put the packages up there. One of the great things about Elm is that it is very easy to understand, very easy to learn, and the more useful Elm packages that are out there for us all to see, I think the better programmers we're all going to be. So you can get copies of the slides and the full demo application on my GitHub. So you can find me here if you want to talk about it or talk about Protolife or whatever. And thank you.